All right, so for these conversions, I would just think about it visually. You can do x equals r cosine and y equals r sine and all of that, but I would kind of just look at them. If you rotate to pi, using a word like up, down, left, or right, where's pi? Left. It would be like you rotate it over to here, so you kind of have to look. You'd rotate over to here, but you're going 3 in the other direction, so it would be 3 this way. So you rotated to pi, but you went 3 in the opposite direction. So what is that coordinate point? Yeah, 3, 0. So same thing for this one. 0, -5 would be here. Like I just kind of visualize it. Now there are an infinite number of answers you can put for polar, but can we go for like the most obvious of it? Okay. What's the amount of rotation to get to here? Yeah, and weirdly, that's the second part of the coordinate. And then we went 5 units in that direction. You could also say -5, comma, pi over 2. Like, do you get what I'm saying? If you rotate to pi over 2 and then go -5. Okay, but just please go for the most obvious one because that'll be easiest. All right, here, we're going to make a little table for theta and r. We're going to start at 0, and it says to go to 2 pi. You want to at least get the quadrant angles for sure. But do you see how there's a 2 in this? Like it's 2 theta. So I'm going to pick up all the quarter angles as well. Like if there was a 3 or a 6 in there, I would pick up all the other ones as well. Like when you're deciding what values to plug in. Because I'm going to have to make it non-calculator, otherwise you'll just type this in your calculator. So again, you have to have a really strong command of the unit circle. So if we plug in 0, cosine of 0 would be 1 times 2 is 2. If you plug in pi over 4, but then you multiply it by 2, it's now pi over 2. What's your cosine of pi over 2? 0. You're going to get a lot of 2s and 0s in this, okay? If you plug in pi over 2, the 2's cancel. Cosine of pi would be -1 times 2, -2. If you plug in 3 pi over 4, but then immediately multiply it by 2, that would be 3 pi over 2, which is going to be, every other one of them is going to be 0, okay? Like it's going to be a pattern. Cosine of 2 pi, if you plug in pi times 2, cosine of 2 pi would be 1 times 2 would be 2. This one we're going to be back to 0. If you plug in 3 pi over 2, the 2's cancel, it would just be 3 pi. So 1 pi, 2 pi, 3 pi would be in the same place as 1 pi. Cosine of that would be what? Good. And then times 2, -2, 0. And then what's the last one going to be? Okay. So let's go ahead and graph them. 0 pi is on this side. If we go 2 in that direction, that's going to put us right here. Then we're to the origin. So it's going to do something like that. Pi over 2 would be right here, but we went opposite 2 units. So that's going to put us down here. As a heads up, this one's going to be a 4-leaf clover. Then we're back to the origin. Pi 2 is going to be here. We went 2 units in the direction of pi, then back to the origin. 3 pi over 2 would be down here, but if you go backwards 2 units, that's going to put you up here. At that point, can you just like keep going? Do you know what I'm saying? Like you don't even need to really look at the table anymore. It's going to look kind of like that. As foreshadowing, like teaser for next time, we're going to start finding the areas of these petals. It is cool. It's neat. Anyway, that's what we're going to start doing next. How do you get an area under a curve? All right, so this says find the derivative. First, you need to find x and y. So x is going to be r cosine theta. So that's going to be secant squared times cosine. And then y is going to be secant squared times sine. This answer is going to be like this long, and we're going to just leave it alone, okay? We're going to do two product rules, right? So dy dx equals derivative for y. All right here, product rule. It's going to be the first thing times derivative of the second, see ya, which will be cosine. Plus the second thing times derivative of the first. Okay. So we're going to bring the 2 down. It'll drop to a 1, which I don't usually write it. And then you have to chain on the derivative of secant. So what's derivative of secant? Secant tangent. It's not difficult. The answer just gets like really long. But I'm not going to make you simplify them, so just leave it alone. All right, now we're going to do dx d theta. So that's right here. So first times derivative of the second, that would be negative sine, plus the second thing times derivative of the first. Hey, didn't we just do that? Isn't it this? Just copy it over. Is there some cleanup you could do with that? Sure, but we're not having to do any more of the problem. It just said find the derivative and that was it. We don't have to set it equal to 0 or do any more work. So I'm not going to bother with it. If I had to, then I would. Or if I had to like plug in a number, which I think the next one I made us plug in a number. Yeah, so like that one. Actually, I probably won't do any algebra with that one either. I'll just plug in whatever the value is. But just leave it. Don't do anything. All right, what is the slope of the tangent line? That means derivative of this at 3 pi over 2. So we're going to do what we just did, except then plug in 3 pi over 2. So same thing, but then actually plug in a value. So what is x going to be? How would we get x?
3 plus cosine plus times cosine.
Good. 3 plus cosine theta. It's this times cosine. That theta is not very good. And then y is going to be r times sine theta. So derivative, we're going to do y first. Product rule, it's going to be the first thing times derivative of the second, which would be cosine. Plus the second times derivative of the first. What would the derivative of this be? Yeah, just negative sine. The 3 is going to go away. And then we're going to do dx d theta. So the first thing, are you like, does it feel like we're writing the same thing over and over again? Because we kind of are. It's not difficult. It's just a little bit of writing. All right, times negative sine plus cosine times negative sine. So that's the derivative. And actually, I'm not going to do anything to that. I am not going to clean that up. I do just want to do the derivative at 3 pi over 2. So now we're going to plug in 3 pi over 2 and just see what we get. So 3 pi over 2 on your unit circle is right here. Just to like help give you the visual. So this first part, it'll be 3 plus, all right, what is cosine 3 pi over 2? Oh, did I make a mistake? Wait, which one are you saying I messed up?
You wrote 3 plus cosine theta and then cosine theta, which is both the original.
then you added those to the.
Oh, no, you're looking at X on the top and Y on the bottom.
Oh.
Y
yeah,
has to go on the
that's
top.
what
So
I did.
first derivative of the second plus second derivative. No, see now you have me.
No, it's right, it's right.
That's
Yeah,
right.
you got it. I would-
Okay, I am right. Okay. Do you just have it
Yeah.
inverted? Okay. No, I want to check though, because I made a mistake typing something in the calculator earlier, which that stuff I carry around. Like it really bothers me, like when I mess stuff up. So if I made 2 mistakes in one block, I was gonna be like really upset. Anyway, where was I? Okay, cosine 3 pi over 2. That's gonna be what?
Cosine 0.
0. Good. All right, and then this would just be 0. Plus, sine of 3 pi over 2 would be -1. So this would be -1. So just 1. All right, and then down here, we would have 3 plus 0. Again, this would be -1, so just 1. And then this would be 0 times 1. I do want us to actually sort through that, because when you do your homework, when it's multiple choice, there's not going to be a multiple choice that looks like that. Like you're going to have to figure it out. What does this entire first part go to? Yeah, this would just be 0 and then -1. So -1. And then this part would just be 0. And then so yes, 3, -1/3.
No, the fact is.
Hey, he was pulling his weight. That's good. I like it.
So,
Well, I usually try to lead everybody through the steps, but if you guys can just tell the answer, just tell me, because I don't want to like go over stuff you guys know. All right. At what values of theta does this equation have a vertical tangent line? Is that dx d theta or dy d theta? For vertical x. Okay, so first we have to find x, and it would be r cosine theta, which would actually be cosine squared. So then that derivative would be 2 cosine theta times negative sine theta. Set it equal to 0. So if you divide it by a negative, 0 divided by a negative is just 0. If you divide it by 2, it's still going to be 0. Really, you're just setting cosine and sine equal to 0. And just remember, you're only going from 0 to pi. So it's only halfway around the unit circle. So where would cosine equal 0 on that interval? Be pi over 2. And sine would be at 0 pi and 1 pi. So those are your answers. If it said horizontal tangent line, it'd be the same process, but what? You do y equals and then dy d theta.